From the College of Business and Economics at Boise State University, this is BUSMBA550. I'm Regis Turpin, and this video we will talk about the basic EOQ model. The goal of this video is to introduce the basic EOQ model. The EOQ model is a very important model because there's a whole family of models that were based on this basic model, but with some changes with some improvement. You'll see that for this basic EOQ model, there are a lot of assumptions that are not always very realistic, but that's a baseline. But let's begin with that very basic EOQ model, and in other videos, I will explain other variation of the model. So the first assumption is that demand for a product is known, constant, and independent. So that's assumption number one, and already you can tell that it's not very realistic. But let's continue. Assumption number two is that the lead time is known and constant. In other words, when you order inventory for replenishment, you know exactly how long it will take and there is no uncertainty about it. Number three, the receipt of inventory is instantaneous and complete. So in other words, you're receiving everything at once. Number four, the quantity discounts are not possible. So that's another assumption that is not very realistic because you know that salespeople are trying to entice you to buy more items, typically by giving you quantity discounts. Number five, the only variable costs are setup costs and holding costs, and I will get back to that in a minute. And the last assumption, which is actually a consequence of all the other one, we never have stockouts in that basic EOQ model. They can be completely avoided. So next, what I want to do is to show you a picture of that because I think a picture speaks a lot in terms of understanding how the model works. So the way it works is that you're ordering a certain lot size and you're going to use it up and then you keep reordering and you replenish it over and over. Obviously, what we're trying to find out is what is the size of that lot size. But we see that we are using it at a constant pace, and that's because the demand is known and constant. If you remember, that's one of the assumptions. And at a certain point, we are reaching what we call the reordered point. And the reorder point is a certain quantity that is going to trigger a reorder. So we know when we have that amount of inventory left, it's time to reorder. And based on the lead time, the truck is going to show up exactly when we're running out of the last unit. And as a result, we are replenished and we are back to square one and again and again. A couple of things to mention about this model. The first thing, and it's going to be an important properties that we'll keep in mind for later. If we keep ordering always the same quantity over and over, you see that the average inventory on hand is half of that lot size quantity. So Q divided by 2 is the average inventory on hand in this model. So let's keep that in mind. Another thing that's important is that the unknown in this equation here, what we're trying to solve the model for is what is the quantity we're going to reorder each time if we want to minimize our costs. So let's talk about the cost now. There are two types of costs associated with inventory, and the first type of cost is called the ordering cost, also known as setup cost. And the setup cost is simply the cost of ordering product, and it's simply a function of how many times you're going to process orders. So if you look at the cost here, the annual setup cost is going to be the number of order placed every year multiplied by the cost of processing each order. Now, the cost of processing each order is a given. It's called S, so that's something that would be given. So let's say $10 per order. That's how much it costs. But as far as the number of order, the way we're going to determine that is by looking at the annual demand and divide by the size of each order. So let's say annual demand is 1,000 and you order in lot sizes of 100, then 1,000 divided by 100, you're going to order 10 times in a year. That's the number of orders, D divided by Q. So overall, the annual setup cost or ordering cost is D divided by Q multiplied by S. Let's keep that in mind for later on. The other part of the equation and the other cost is the holding cost. And the holding cost is simply the cost of holding those items in a warehouse in inventory. That cost is directly proportional to the amount of units of inventory that we have on hand. If you remember in my picture, I mentioned that the average level of inventory is the quantity divided by 2. That's where we're using it because the annual holding cost is the average inventory level that we have multiplied by the cost of holding that item and the cost per unit. So annual holding cost is Q divided by 2 multiplied by H, which is the cost of holding those items. So now we have everything that we need. Now, the goal of the EOQ model is to minimize the sum of those two costs. So that's the setup cost and that's the holding cost. And I'm going to show you in a picture how that works. So this picture here is a graphic representation of all the costs that I just mentioned. So the first cost is the holding cost, and as you see, it's a straight line here because there's a linear relationship between how many units I hold in inventory and the cost of holding those units. Okay, so if I have 0 unit in inventory, I will have 0 cost. Now the green line here represents the setup cost. So the larger the quantity we order and the less often we need to process orders, and therefore the less it would cost to process those units. The EOQ model says that if you are rational, you are going to try to minimize the sum of those two costs. That's the red line at the top here. Now, let's take two very extreme cases to explain how the model works. So, let's imagine you have a company that wants to order large volume. Basically, their goal is to order inventory only once a year. So, we'll be on this side here. So, if they did that, of course, the quantity they would order would be extremely high. So, would be here. But on the other hand, because they would process only one order per year, then the cost of ordering will be very low. So that's one extreme. Now I want to illustrate another extreme, which is also not very realistic and a bit absurd. So imagine you have another company this time who never wants to have more than 1 unit of inventory in their warehouse. So they would be right here. So they would reorder every time they use 1 unit. If they did that, of course, the cost of holding inventory would be very low, but the cost of ordering would be very high because you would have to process an order for every single unit. So that would be extremely high. Now, the two scenarios I just described are a bit absurd, but you could see that the minimization or the optimal point would be somewhere in between here. And the EOQ formula is helping us solving that. Now, you may have noticed that in this curve here, the optimum point or the minimum cost is taking place at the point where holding cost is equal to setup cost. So we're going to use that property to solve our equation for the minimum total cost. So if we look at the total cost function that I was showing on the previous slide, the total cost function is going to be minimum when we have this cost equal to this cost. So that's the setup cost, the annual setup cost is equal to the annual holding cost. So let's solve for that. So this slide here shows you the calculation. So I set those two costs as equal. That's the setup cost, that's a holding cost. I extract the quantity. So I have Q square is equal to 2ds divided by H. And finally, I solve for Q, and Q would be equal to square root of 2ds divided by H. That's the EOQ quantity. That's the quantity that is going to allow me to minimize my costs. Let's use that on an example. So let's imagine I have this scenario where demand is 1,000 units. The cost per order is $10. That's the setup cost. The holding costs are 50 cents per unit and per year. Now, on top of that, I have a lead time of 3 days. So it takes me 3 days to receive my new inventory when I reorder it. So the first question I'm asking is, what is the optimum number of unit to order? And the way we do it is simply by plugging the number into the equation. So that's the EOQ quantity. I plug the numbers in there. And ta-da, here it works exactly as a round number. It's not always going to be that simple, but here it works really well. So my optimum quantity is 200 units here. Next question, how many orders would I process per year? Well, you remember that my demand was 1,000. Well, the number of orders I'm going to process every year is 1000 divided by 200. And therefore, I'm going to order 5 orders per year exactly. Next question is what will be the time between order? And this one is very simple. You're going to take the number of days in 1 year and divide by how often you order. For the sake of simplification here, I assume that the company was working 250 work days per year, just a way to make work easier. But if the company was working 365 days, you could do 365 divided by 5. So here it's 250 divided by 5. What it means is that you're going to have 50 days between each order, or another way of saying that is you're going to process one order every 50 work days. Next question is what would be the minimum total cost under those conditions? Well, I'm taking the total cost function and I plug my numbers here and I'm replacing the quantity here by the optimum quantity, EOQ quantity that I computed before. That's 200. And you see what happens here that is interesting is that when I do that, I find that my setup costs are the same as my holding cost. And that shouldn't come as a surprise because if you remember the way we solved our equation was by setting those two costs as equal. So it's normal. You should always have that. That's expected. So the minimum total cost would be $100. Last question. What would be my reorder point? So the reorder point, I remind you, is the quantity that should trigger a new order. And for that, you need to figure out what is the daily demand. So if my annual demand is 1000 units and I have 250 work days per year, then I'm going to process 4 units every work days. So based on that, if my lead time is 3 days, it means that during those 3 days, I'm going to process 12 units. And therefore, 12 units is my reorder point. When I have only 12 units left in my inventory, I know it's time to reorder. And if I reorder at that time, the truck is going to show up exactly when I'm using my last unit from the previous batch. This is the end of this video. In my next video, I will talk about the EOQ model with quantity discount.